was born Karl Ernst Ludwig Marx Planck, in Göttingen, Germany in 1858. He came from a family of theologians and scholars and always loved music and science. Years later, he fondly recalled how his high school teacher inspired him to love the first law of thermodynamics, that energy was conserved, by having his students imagine the energy in a heavy stone lifted onto a roof that one day might be, quote, loosened and drop on the head of some passerby. Planck thought it was a revolution to find that laws possess absolute universal validity independent from all human agency, and decided that the quest for laws as the most sublime scientific pursuit in life. As a teenager, he went to study physics at the University of Munich, where he's told by his professor to drop physics because, quote, all the fundamental laws had already been discovered. But Planck ignored him. And after 3 years at Munich, he went to the University of Berlin, where some of the top scientists in the world were located. Specifically, Planck wanted to study under Hermann von Helmholtz and Gustav Kirchhoff. However, Planck found that he liked Helmholtz as a person, but found his lectures to be miserably bad. So much that Helmholtz's class dwindled to just 3 students, including Planck, who seemed to just stay out of politeness. Kirchhoff was not much better, and Planck realized that, quote, my only way to quench my thirst for advanced scientific knowledge was to do my own reading on subjects which interest me. This is how he encountered the works of another German scientist named Rudolf Clausius. Now, Clausius had came up with the idea of entropy in 1854 and the name entropy in 1865, and had defined the second law of thermodynamics to be, quote, the entropy of the universe tends to a maximum. Planck was just as excited about the second law as he was about the first. He even got his PhD in entropy when he was just 21 years old in 1879, although Helmholtz and Kirchhoff were unimpressed. Years later, Planck recalled, Helmholtz probably did not even read my paper. Kirchhoff expressly disapproved of its contents. Undeterred, Planck dedicated the rest of his life to the study of energy and entropy. While he was at Munich, Max Planck fell in love with Marie Merrick, the younger sister of one of his friends. Planck waited till he got a professorship before proposing, and waited and waited. In his biography, he recalled, I waited for years in vain for an appointment to professorship, and nursed the desire to win, somehow, a reputation in the field of science. 6 years later, he finally lucked into a position at the University of Kiel, probably with the assistance of his father's friend. In 1887, he finally married Marie Merrick, whereupon she had 4 children in rapid succession. Karl in 1888, twins Emma and Greta in 1889, and Erwin in 1893. Planck was a devoted husband and father and enjoyed spending time with his family, going on marathon hikes or playing music. He wrote to a friend, quote, how wonderful it is to set everything else aside and live entirely within the family. Planck's former student Lisa Meitner recalled, Planck loved merry, relaxed company, and his home was the center of such conviviality. She added that even years later, he would play marathon games of tag in the yard with his students and with his children. Planck participated with downright childish glee and great adeptness. It was almost impossible not to be tagged by him. And how visibly pleased he was when he caught someone. At about the same time the twins were born, Gustav Kirchhoff died, and Planck was offered his position at the University of Berlin, where Planck stayed for the rest of his career. At Berlin, Planck became interested in using entropy to explain an experiment created by the same Gustav Kirchhoff 30 years before, called black body radiation. Planck recalled, quote, it was an odd jest of fate that the lack of interest in my colleagues in entropy now turned out to be an outright boon. While a host of outstanding physicists worked on the problem, nobody paid any attention to the method adopted by me. It took Planck 6 years, but in 1900, Planck triumphantly produced his results. Then a co-worker of Planck's gave him some disturbing news. At relatively low energies, the equation that Planck just derived from fundamental equations didn't work. And so Planck quickly made up a new equation, quote, which as far as I can see at the moment, fits the observational data. Planck was happy his equation worked, but he was not happy that it didn't have any theoretical backing. So in a self-described act of desperation, he turned to Ludwig Boltzmann's method of looking at statistics with molecules and entropy. Previously, Planck rejected that because he didn't like treating energy as a law of probabilities, but he was out of options. So he decided to relate the entropy S to the probability W with the following logic. Since the entropy S is an additive magnitude, but the probability W is a multiplicative one, I simply postulated that S equals K log W, where K is a universal constant. But then Planck had a problem. If the energy is considered to be continuously divisible quantity, this distribution is possible in infinitely many ways. For that reason, Planck constrained the energy to be created in little energy packets with energy equal to a constant h times the frequency. Planck was very happy about the results, especially for the value of k, currently called Boltzmann's constant. However, Planck didn't think much about his equation where he put the energy of the light into little energy packets, or quantized them. Quantizing energy was to Planck, quote, a purely formal assumption, and I didn't give it much thought. However, he did spend many years trying his best to weld the elementary quantum of action h somehow into the framework of classical theory. But in the face of all such attempts, this constant showed itself to be obdurate, which is a good word, but I'm not sure I'm pronouncing it correctly. Then, in March of 1905, Planck was the editor of Germany's major scientific publishing paper, and he got a paper from an unknown scientist named Albert Einstein. Einstein took Planck's formal assumption of light being composed of energy packets as being a profound statement about the nature of light and used it to explain a variety of phenomena, including the photoelectric effect. Surprisingly, Planck was completely unimpressed with Einstein's development of his idea, although he let it be published. A few months later, Planck received another paper from Einstein, this one on special relativity, and Planck was entranced. In fact, Planck became the first person to give a public talk on special relativity, crediting Einstein, of course, dedicated most of his research to it, and became the first person to prove that you could get the ideas of general relativity from the principles of least action. Years later, Einstein recalled, quote, it is largely due to the determined and cordial manner in which Planck supported this theory that attracted notice so quickly among my colleagues in the field. Planck and Einstein started writing each other, and Planck encouraged Einstein to focus on relativity and drop quantum mechanics, a request that Einstein ignored, working on both things as well as working 6 days a week at the patent office. For example, in 1907, Einstein wrote 8 papers, including one that used Planck's idea of energy elements to understand how solids emit and absorb heat, and his first paper on general relativity. By August of 1909, Planck invited Einstein to give his first public talk. Planck was probably hoping Einstein would talk about relativity, but instead Einstein talked about quantum mechanics, once again pushing a theory of light that can be understood as a kind of fusion of the wave and particle theories. Years later, a member of the audience recalled that the talk went nowhere, as the chairman of the meeting was Planck, and he immediately said it was very interesting, but he didn't quite agree with it. A few months after Einstein's first talk, tragedy hit the Planck household. Planck's wife of 23 years, Marie Planck, died from tuberculosis. Max Planck buried his wife and told his cousin that her grave is where, quote, my lost happiness is sleeping. Planck was 51 years old. His oldest son was 21, the twins were 20, and his youngest was just 16 years old. His relationship got much closer to his family, especially his youngest, Erwin. But then the children were shocked when a year and a half later, he married their cousin. His former wife's 28-year-old niece, Marga von Hoslin. Marga continued to occasionally call her husband Uncle Max, even after the marriage. But it seems to have been more than a platonic relationship, as Marga gave birth to his fifth child, Hermann, in December of 1914. Meanwhile, back in 1906, a German scientist named Walther Nernst came up with an astonishing idea while trying to create nitrogen-based fertilizer. Nernst decided that two chemistry terms became identical asymptotically at absolute zero, which seemed to imply that the entropy would also asymptotically go to zero at absolute zero temperature, although Nernst hated talking about entropy. Within months, this theorem was being referred to as the third law of thermodynamics. Planck became the first theoretician to support Nernst in his theories, and also in 1910 became the person to figure out that the idea that entropy goes to zero was not true if the item was a compound or made of more than one substance. This rewrote the third law to be, quote, the entropy of a pure solid or pure liquid approaches zero at 0 Kelvin. A few years later, Nernst created his own final version of the third law to be, quote, it is impossible to cool an object to absolute zero. Scientists to this very day are still arguing about the proper form of this law. Anyway, in the spring of 1910, Nernst read Einstein's 1907 paper about using quantum mechanics to study solids and realized it could be used as a theoretical validation of his heat theorem. And within weeks, Nernst started talking with a wealthy soda magnate named Ernst Solvay about creating a conference on quantum issues starring Einstein. Nernst then immediately sent a letter to Max Planck detailing the whole plan. Planck was a little skeptical that the timing was right, writing that, quote, such a conference will be more successful if you wait until more factual material is available. However, Planck added that, whatever is done in this regard, I shall take the greatest interest, because I can say without exaggeration that for 10 years, nothing in physics without a break has absorbed, excited, and attracted me as these quanta of action. Nernst ignored the request to delay and personally set up the first international science meeting, called the Solvay Conference, beginning in October of 1911. Neither Planck nor Nernst knew that Einstein was less excited about the conference than Planck was. See, he had been trying to meld Planck's quanta of action, H, into Maxwell's equations with no luck. But Planck and Nernst were too famous to refuse, so he put together what he told his friend was some twaddle for the conference. Einstein thought the conference was a disaster, but the rest of the attendees were fascinated. Both Planck and Nernst realized that Einstein was a science superstar, and they quickly started a push to get him to Berlin. By July of 1913, Max Planck and Walther Nernst personally traveled to Zurich to offer Einstein a plum position at the University of Berlin, which he eagerly accepted because it involved less teaching, and so he could be near his cousin, with whom he was having an affair. Blah. Anyway, in Berlin, Einstein and Planck became incredibly close friends and spending many evenings together playing music. Einstein played violin, Planck played piano. At the same time, July 1913, the Max Planck and Walther Nernst were offering Einstein a job. A young Danish man named Niels Bohr heard about the Solvay conference, and it inspired him to create a new model of atoms using Planck's constant H. Bohr's paper hit the scientific community like a thunderbolt. See, people had known since the 1800s the hot gases don't make rainbows of light, but instead make a distinctive frequency of light, and was called spectral lines or spectroscopy. It seemed logical that if light came in little quantized energy packets and adheated gases make little quantized colors of light, that those two things should be related. In fact, way back in February of 1909, Max Planck wrote in his notebook that he was, quote, fully convinced that the problem of spectral lines is intimately tied to the question of the nature of quantum. But no one, including Planck and Einstein, had gotten anywhere with it before. What made Bohr's model so different is that he stated that the energy that light produced told you nothing about the energy of the electron itself, but only told you about the quantum change of energy as it jumped from one energy level to the other. With Bohr's new model, you could predict the spectral lines for hydrogen and for helium ions, helium with only one electron. Even that was astonishing to scientists. 7 years later, Planck gushed, Bohr discovered the long-sought key to the entrance gate into the wonderland of spectroscopy. And now that way was opened, a sudden flood of newfound knowledge poured over the whole field, including the neighboring fields in physics and chemistry. Quantum mechanics was about to change everything, and Planck was at the center of it. Sometimes inspiring and even financing, and sometimes restraining the work of Heisenberg, Schrödinger, Born, Lau, Meitner, Hahn, and more. In the midst of all that, Planck suffered, and oh, he suffered, with a slew of personal tragedies, living through 2 world wars and the depression between them. And that story is next time on the Lightning Tamers. Thanks for watching my video. Sorry I had to split it up with the wars in another video. I should get that out really soon. And when I'm done with that, I promise I will make a video about Niels Bohr's model, because it's so cool and it's so interesting and it's so influential. And I get to talk about Ernest Rutherford again. And I love me a little bit of Ernest Rutherford. I just love him. Remember, give me a thumbs up, share it on social media, all that jazz. If you want to be more supportive, you can become one of my patrons. Thank you, Patreons. I really